I've been coding in C# using the Unity game engine for over 3 years now, and you'd hope I've had amassed quite a bit of knowledge in the field. Soulcube runs local educational events, and we're also active on our community Discord forums, so I'm regularly exposed to helping beginner game developers. And I think sometimes they tend to forget that we all had to have started off from somewhere, and there was a point in my game development career where I didn't know what an array was. So in this video, I'm going to be running through the top 5 Unity programming things that I wish that I had found out sooner. Number 6. Accessing values across scripts. Believe it or not, there was a good few months of game development where I had no idea how to share values between scripts. I would scour the Unity forums attempting to find answers. All I wanted was for a script to talk to another script, and I was so perplexed as to how to go about doing so. I need to stress that this isn't a complex issue, and nor is it a complex issue to find the solution to. But this is one of the first issues that I faced, and as such, my problem-solving technique was still in its early days. See, while I had been scouring the internet to seek answers for my problems, I could have searched and searched and searched, but if I'm not searching for the right things, then I'm never going to find what I'm looking for. After being a game developer for a while, or any sort of programmer for that matter, you hone in on the formatting of searches, the art of Google. You don't search, in Unity, how do I make my player make its mace swing? You need to identify exactly what it is you're searching for and frame it as a blunt statement, as broad as possible. In this scenario, the information needed would be how to call a function on a mace object from a player script. So a more appropriate search would be something like Unity call function on different object, or Unity call function on external object, or Unity access script on object. I remember when I finally found out how to talk between scripts, it was due to some random YouTube tutorial where some guy just had 2 blank cubes that just sent stuff to each other, and I thought, man, this is absolutely revolutionary. I thought this was the bee's knees programming, could not get much better than this until something new came along. Number 5, Singletons. Bam! So you like big chunky game manager classes? You like big chunky player classes? Man, chances are if you're a proficient programmer, you won't. But I reckon most of you are watching aren't, so Lord and behold, the Singleton. So you got this chonker of a class that every man and his dog in your game needs to access in some way. Sure, you can drag and drop a reference in the Unity editor. What about objects that are getting spawned in at runtime? You can't exactly just pop open the editor and drag that stuff in while old mate on the other side of the world in Madagascar is playing your game, I mean, you can probably find the object with your massive class on it with a tag search, but that's pretty taxing on the computer. So instead, big man Singleton comes in to save the day. A static instance of the class means that we can reference this sucker anywhere, anytime. 5.5. Runners up. Now look, this baby doesn't get its own number, but I thought I'd include it while on the topic of singletons and call them functions. Events. So events can be thought of like subscriptions. An event can be invoked after a certain thing is happening in the game, calling all functions that have been subscribed to this event. Say you need several things to happen when an enemy dies? Well, don't call them all from a central script. Have each function subscribed to an event that is invoked when an enemy dies. Number 4. Functions are back at it again with number 4. It was probably a solid year into development before I realized what the heck void meant in the declaration of all these functions. The function returns nothing. Returns nothing? I thought. Well then, what could it return? Well, just about anything, my young Padawan. Have some difficulty coefficient that's calculated using a bunch of different pronumerals? Whack that sucker's definition as a function. Need to access components on an object instantiated at runtime? Well, guess what? That function has a return type of game object. We already got the reference, so we're good to go. Number 3. Class inheritance. Alright, so check out this tree. At the top we got an enemy Joe. He can't do jack all. His frob's got some health and the ability to move and attack. That's what Joe's got. Stemming down from Joe, we've got aggressive Greg and sneaky Steve. These dudes are pretty similar to Joe. They inherit all of his attack and health systems, but they each have different movement code. Then, if you stem down from Aggressive Greg, you've got Mace Mike, Sword Simon, and Bo Barney. These guys have the same health, movement, and attack stuff that's been inherited from Joe, except now they also have the movement that's inherited from Greg, and now they each have their own attack code for their respective weapons. And now if we stem down from Mace Mike, he can turn into Mr. Mace Mike, an enemy that's inherited health, movement, and attack code from Joe, but then has also got the movement code from Greg, but then also the attack code from Mike, and now he's also got his own health code, allowing him to regen. And then if you stem down from Mr. Mace Mike, he can turn into class hierarchies. Pretty cool. Just derive the class here, and label any functions you want to override as virtual on the parent class, and then label the overrides as simple as an override, and there you go. Laughing like a fat spider. Number 2. Function parameter mastery. Remember when I first understood the concept of parameters? You have a function that does a thing, but you know this thing needs some information to perform its task. You deliver it that information through parameters, where it whips up some temporary variables to assign this information to so the function can use it. Absolutely banging efficiency, as before, I'd just be permanently storing all this meaningless data on the class. The problem is, when you've got a chunky code base that's calling an important function quite a bit, if you add more parameters to that sucker, you're going to get syntax errors from every single reference to that function. Oh my god, not epic. Introducing default parameter values. All those old references don't need to care about the new parameter. Well, screw it, just make it default to null and Bob's your uncle. Number 1. Stuff that everyone should know, but we avoid it. Enter saving data. Credit to where credit is due, Big Man Brackies has a mad tutorial on how to create a binary save file system for saving data in your games, and it's really easy to use and adapt. I recommend, if you have plans for your game, being able to save, you begin development with this system in place, as it makes it much easier to manage how you develop all of your classes, and as such, introduce limitations on what kind of data can be stored in a file. Saving data is something that every man and his dog needs to know, but a lot of us push it back to the last minute, and I'm guilty of not picking it up sooner to master it. Well, there you have it, folks. Just 6 things I wish I'd found out sooner programming in Unity. Let me know what are some things that you wished you had found out sooner. Did I miss any of your crucial ones? Thanks so much for watching, and if you want to join the SoulCube community, you can dip on over to our Discord server, where we hold a plethora of community events, including art and music and meme competitions, game dev discussions, questions, chill community games, and more. And, some of these actually have some monetary prizes. So hop on in. You can also check out our other socials. We've got Instagram and Twitter and Twitch. Like, share, and subscribe. And, we'll catch you in the next one. Neck one? What?